Hello and welcome to this lecture. In this lecture, we will talk about updates and rollbacks in a deployment. Before we look at how we upgrade our application, let's try to understand rollouts and versioning in a deployment. When you first create a deployment, it triggers a rollout. A new rollout creates a new deployment revision. Let's call it revision 1. In the future, when the application is upgraded, meaning when the container version is updated to a new one, a new rollout is triggered and a new deployment revision is created named revision 2. This helps us keep track of the changes made to our deployment and enables us to roll back to a previous version of deployment if necessary. You can see the status of your rollout by running the command kubectl rollout status followed by the name of the deployment. To see the revisions and history of rollout, run the kubectl rollout history command followed by the deployment name, and this will show you the revisions and history of our deployment. There are two types of deployment strategies. Say, for example, you have 5 replicas of your web application instance deployed. One way to upgrade these to a newer version is to destroy all of these and then create newer versions of application instances. Meaning, first destroy the 5 running instances and then deploy 5 new instances of the new application version. The problem with this, as you can imagine, is that during the period after the older versions are down and before any newer version is up, the application is down and inaccessible to users. This strategy is known as the recreate strategy, and thankfully this is not the default deployment strategy. The second strategy is where we do not destroy all of them at once. Instead, we take down the older version and bring up a newer version one by one. This way the application never goes down and the upgrade is seamless. Remember, if you do not specify a strategy while creating the deployment, it will assume it to be rolling update. In other words, rolling update is the default deployment strategy. So we talked about upgrades. How exactly do you update your deployment? When I say update, it could be different things, such as updating your application version by updating the version of Docker containers used, updating their labels, or updating the number of replicas, etc. Since we already have a deployment definition file, it is easy for us to modify this file. Once we make the necessary changes, we run the kubectl apply command to apply the changes. A new rollout is triggered and a new revision of the deployment is created. But there is another way to do the same thing. You could use the kubectl setImage command to update the image of your application. But remember, doing it this way will result in the deployment definition file having a different configuration. So you must be careful when using the same definition file to make changes in the future. The difference between the recreate and rolling update strategies can also be seen when you view the deployments in detail. Run the kubectl describe deployment command to see the detailed information regarding the deployments. You will notice when the recreate strategy was used, the events indicate that the old replica set was scaled down to 0 first, and then the new replica set scaled up to 5. However, when the rolling update strategy was used, the old replica set was scaled down one at a time, simultaneously scaling up the new replica set one at a time. Let's look at how a deployment performs an upgrade under the hood. When a new deployment is created, say to deploy 5 replicas, it first creates a replica set automatically, which in turn creates the number of pods required to meet the number of replicas. When you upgrade your application, as we saw in the previous slide, the Kubernetes deployment object creates a new replica set under the hood and starts deploying the containers there. At the same time, taking down the pods in the old replica set following a rolling update strategy. This can be seen when you try to list the replica sets using the kubectl getReplicaSets command. Here we see the old replica set with 0 pods and the new replica set with 5 pods. Say for instance, once you upgrade your application, you realize something isn't very right. Something's wrong with the new version of build you used to upgrade. So you would like to roll back your update. Kubernetes deployments allow you to roll back to a previous revision. To undo a change, run the kubectl rollout undo command followed by the name of the deployment. The deployment will then destroy the pods in the new replica set and bring the older ones up in the old replica set, and your application is back to its older format. When you compare the output of the kubectl getReplicaSets command before and after the rollback, you will be able to notice this difference. Before the rollback, the first replica set had 0 pods and new replica set had 5 pods, and this is reversed after the rollback is finished. And finally, let's get back to one of the commands we ran initially when we learned about pods for the first time. We used the kubectl run command to create a pod. This command, in fact, creates a deployment and not just a pod. This is why the output of the command says deployment nginx created. This is another way of creating a deployment by only specifying the image name and not using a definition file. The required replica set and pods are automatically created in the backend. Using a definition file is recommended though, as you can save the file, check it into the code repository, and modify it later as required. To summarize the commands real quick, use the kubectl create command to create the deployment, getDeployments command to list the deployments, apply and set image commands to update the deployments, and rollout status command to see the status of rollouts, and rollout undo command to roll back a deployment operation. That's it for this lecture. We will now head over to a demo, and I will see you in the next lecture.